In this lesson, we are going to be solving quadratic inequalities. And what that really is that's going to be a graphical solution because we're dealing with inequalities, and as we did with lines, these are going to have shading. So let's review the steps. And this is going to be remarkably like how we graph linear inequalities. The first thing you're going to do is you're going to actually graph the quadratic equation, and you're going to use a solid line if there's an equal to sign in the inequality, and you're going to use a dashed line if there's not, just like we did with linear inequalities. Once you've graphed the inequality and you have the right kind of line, whether it's dashed or dotted, you're going to decide whether you're going to shade inside the parabola or you're going to shade outside of it. And it's just like with the linear inequalities, you're going to pick some point, you're going to test it. If it's true, you're going to shade wherever that point is. If it's not true, you're going to shade the other side, whether it be the inside the parabola or the other side or the outside. So let's go ahead and try that. Now, some of the examples that I have here, they're all in standard form. That seems to be what the book likes. But you could get one that's in vertex or intercept form. You'd use the same procedure. So let's go ahead, and what we have is we have y is less than negative x squared minus 2x minus 1. Notice that there is no equal to sign, so this will be a dashed parabola. And let's find the axis of symmetry since it's in standard form. So what we're going to do is we're going to go ahead and graph it like there was an equal to. So we'll think of it in terms of y is equal to a negative x squared minus 2x minus 1, where the axis of symmetry is going to be equal to a minus b. So that's going to be a negative, and b is a negative 2, so it's negative of a negative 2. All over 2 times a, 2 times a negative 1, which would be equal to 2 over 2, which is equal to 1. So my axis of symmetry is equal to 1. That's also where the vertex is. So let's put the value of x equal to 1 back into the equation and see what the y value is. So what I would have is I would have y is equal to a negative of the vertex, the x-coordinate is 1, so that would be 1 squared minus 2 times 1 minus 1. That would be a negative 1 minus 2 minus 1 minus 1 minus 2 is negative 3. It'd be equal to a negative 4. So my vertex is at 1, negative 4. Okay, that doesn't seem right to me, so let me try that again. I think I probably made a mistake up there. Let's try it again. So the axis of symmetry is equal to a minus of a negative 2, so that's a positive 2. 2 times a negative 1 is a negative 2, so my axis of symmetry is a negative 1. Okay, so my vertex is going to be a negative 1, and let's figure out what y is. So y is equal to a negative of a negative 1 squared minus 2 times a negative 1 minus 1. So that would be a negative 1 squared. That's a negative 1. That would be a negative 1 plus 2 minus 1. So that would be 0. So my vertex is at a negative 1, 0. And let's find another point to plot. Okay, remember when I had my axis of symmetry equal to 1, I had a y value of a negative 4. So although that was a mistake, I already know what it's going to be if I plug 1 into the equation. So my second point that I'm going to plot, I would pick a point of 1 for x, and I already know that the y is going to be a negative 4. So let's plot that. 1. That's 2-way on this side, so let's put 2-way on the other. And it's a dashed parabola. Okay, so there's my parabola, and let's test a point. I'm going to test 0, 0 and see if that works. So plugging 0, 0 into the original inequality, I would have 0 is less than 0 minus 0 minus 1. 0 is less than a negative 1. So here's my point 0, 0, and we're tested and have 0 is less than negative 1. That's false. So the point 0, 0 would not be shaded. It would have to be the other part, which would be inside the parabola. So that would be shaded, and that would be my answer. Okay, let's do another one. This one is also going to be a dashed line, and let's find the axis of symmetry for this. So what we're actually going to plot is y is equal to a negative x squared minus 2x plus 15. So let's go ahead and plot that. The axis of symmetry is going to be at x is equal to a minus b. That would be minus a negative 2 all over 2a, which would be 2 times a negative 1. So my axis of symmetry would be equal to 2 over a negative 2, equal to a negative 1. Okay, so let's find out what the y value is when x is a negative 1. So I know the x-coordinate of my vertex is a negative 1. Let's pick y. So y is equal to a negative 1 squared minus 2 times a negative 1 plus 15. That would be a negative 1 squared is 1. Be a minus 1 plus 2 plus 15. That would be 16. So my vertex is equal to 1, 16, negative 1, 16. Okay, and let's find another point. I'm going to put 1 into the equation, so my second point. Pick 1. And if I put 1 into the equation, I would get y is equal to a negative of 1 squared minus 2 times 1 plus 15. That would be a negative 1 minus 2 plus 15. That would be equal to 12. So I have 112. So 1, 2. So I'm 2 on the other side. It's going to be a dashed line. Okay, let's test the point 0, 0. That would actually be inside the parabola. So testing 0, 0. I would have 0 is greater than 15. That's false. So the point 0, 0 was not shaded. That's inside the parabola, so this one would be shaded outside. Okay, now we have a situation where we're graphing a system. That's going to be 2 parabolas. And what we're going to do is we're going to have the overlap of the shading would be the true solution. So just like when I did lines and I shaded one side of the line, then I shaded it I had another line and I shaded it, it's where the overlap, that would be the solution. So let's see what we have. So for the first one, I'm just going to call this equation 1. Let's go ahead and plot that. This is in vertex form. So what we could do is think of this as the h value is going to be equal to 0. Notice that that's x minus h, so h is 0. So for my first equation, I have h equal to 0, k is 3. So my vertex would be at 0, 3. And then I need to test another point, or plot another point. So let's pick, say, x is equal to 2, say. So at x equal to 2, so if x is 2, I would get a minus 2 squared plus 3. That would be a minus 4 plus 3. That would be equal to a negative 1. So I would get 2, negative 1. Then I have the mirror point on the other side. That would be a dashed line, or dashed curve, because it's a no equal to. And let's test a point. We're going to test 0, 0. And I would get 0 is less than 3, which is true. So this one would be shaded on the inside. Okay, let's plot the other one. I'm going to call that 2, and I'm going to use a different color. Okay, so for number 2, that's in standard form. The axis of symmetry is going to be at x is equal to a minus b all over 2a, a minus 2 all over 2a, which is 2. It's going to be at a negative 1. Okay, so the x-coordinate of my vertex is a negative 1. Let's plug a negative 1 into the equation and see what y is. So y is equal to a negative 1 squared plus 2 times a negative 1 minus 3. That would be equal to a negative 1 squared. That would be 1 minus 2 minus 3. So that would be equal to a negative 4. So my vertex for this one is at negative 1, negative 4. Let's go ahead and put that on there. And let's pick another point. I'm just going to pick x equal to 1. And if I put 1 into that equation, I get 1 squared plus 2 times 1 minus 3. 1 plus 2 minus 3 is equal to 0. So the point 1, 0. So the mirror point will be over here. It's going to be a solid curve. And you can see that 0, 0 is inside of the parabola. On this one also, let's go ahead and test it. Test 0, 0. And that is going to be giving me 0 is greater than or equal to a negative 3. That's true. So we'll shade inside that parabola. And you can see that the overlap of my shading is going to be this region in here. And any point that would be on this dashed line would not be a solution. Any point that would fall on this part of the blue line would be a solution. So that's how we plot a system of quadratic inequalities. And to save time, I don't think I'm going to work the other example out. I think you get it. That should be enough.